Good morning, everyone. Today we're going to start our discussion on machine learning. So I was mentioning a while ago that machine learning has different forms. Okay, the three main basic types of machine learning are supervised learning, unsupervised learning, and reinforcement learning. In these sessions that we're going to have, we're going to focus on supervised learning. It's the easiest of the three because the data is structured, okay, which means that the variables are well defined. And for supervised learning, uh, one of the most popular method here, or let's say process, is CART. CART stands for Classification and Regression Trees, CART. Okay, so today we're going to have an example of uh, supervised machine learning using the tool called decision tree. So we're going to make use of this library, Party and Tidyverse, in order to load our data. So if you haven't installed this is a partitioning. This is a partition. Okay, the Party library. Kindly install it now, and Tidyverse in order to load our data. So let me go here to packages while you're loading, and let me just open the help function for the Party package. Party. I've already downloaded this. So a laboratory for recursive partitioning. Okay, so this is used for decision trees. All right. So let me just use the description file. Okay. So the Party package is a lab for recursive partitioning. So this was developed by Thorsten. Okay, Thorsten is the main author, and then also Hornick, Strobel, and Xiles. Okay, so this is a computational toolbox for recursive partitioning. The core of the package is C3. So this is what we're going to use later. An implementation of the conditional inference trees, which embed three structured regression models into a well-defined theory of conditional inference procedures. Now, don't get me wrong, yung CART class, yung classification doon, regression din yun. No? Only that what you're regressing are binary variables. No? Hindi siya yung quantitative, but we're just making the distinction between classification and regression. Oh, I'm not showing. Okay, sorry. Oh, I'm sorry. Okay, sorry, I wasn't showing my screen. All right, so let me backtrack a bit. So as I said, you have to install and require the Party package, the Tidyverse for loading the data. And as I said, also I looked at packages and then type Party. Okay, and then it brought me here, right? So these are some of the some information about the package. Back, go back, and then this is the documentation. So these are the functionalities that come with the Party package. Okay, so this is the main function C3. Let me open that. Conditional inference trees. This is from the Party package. It's recursive partitioning for continuous censored ordered nominal and multivariate response variables in a conditional inference framework. So you have the some information here. We'll start with the basics, and then we will try to use other other functions of the C3 based on our example. Okay, so you have here examples. You might be interested to look at this example. We're not going to use this, but I suggest that you also look at those examples uh, by yourself. Okay, so the data that we're going to use is what I gave you, the cardio data. So let me run this. Okay, so this is the cardio data. Okay, let's have a brief look at it. There are 2,126 observations and 22 variables all in all. So these are information or data about individuals, say heart, and then there are some here. There are some metrics here, but I will not go into the details of this, but these are information about the person's heart condition, the blood condition. And here we have the classification variable, NSP. N stands for normal, S stands for suspect, and P stands for pathologic. Okay, so there are 3 levels here: normal, suspect, and pathologic. So this is based on the doctor's, let's say, a prognosis or findings about the person. So this person is suspect to heart disease. Okay. Person number 2 is 1, normal, and number 3 is pathologic. It means that the person is suffering from heart ailment. Okay. So the objective here is to use some of the variables here in order to determine or predict whether the person is normal, suspect, or pathologic. In other words, we're going to use machine learning in order to predict, okay, the respondents, and then we're going to check whether our model is okay or not based on measures of R-squared, Ramsey, mean absolute error, mean absolute deviation, etc. Because those are the metrics that we can use in order to determine if our model would suffice. Okay, in a regular way, we can use multinomial regression here, but the mathematics behind multinomial regression is more involved as compared to the machine learning method. Okay, so let's go back to our file. Okay, saan na ako? Dito. Decision tree. Balik mo nga dun. Malapit dun sa cardio data. Okay, so we have, based on the view. Okay. So siguro tingnan din natin, class, kung ano, no, kung ilan yung ano, yung dito lang sa describe data. We can use the structure. Okay? Pwede rin natin gamitin table ni cardio $NSP. Yan. Let's take a look at the tabulation of NSP dito sa cardio, no? Run this. So dun sa ano natin, sa data set natin, 1,655 were normal, suspect 295 at saka pathologic 176. So there were more respondents, there were more in the sample who were normal as compared to pathologic. And then of course we can make use of the structure. So this is a data frame consisting of 2,126 observations by 22 variables. Tapos lahat ng variables natin are numeric. And actually iisa lang yung ano natin, yung qualitative, no? Yung categorical. Okay, and then here our variable of interest is NSP. Okay, this is a categorical variable that classifies into normal, suspect, or pathologic. Okay, now summary. Now if we take a look at this, class, notice that our NSP is numeric. Diba? Now we don't want that kasi ang NSP natin dapat ano yung qualifier or factor dapat siya, no? Okay. So factor dapat siya. Okay, of course, we know the summary. Sige, run natin to. Okay, so we have here all the variables having quantitative. That's why na-measure natin yung minimum, maximum, etc. Si ano din, si NSP. Okay, so this has no sense kasi hindi naman talaga mini-measure yung NSP, no? Count lang to. So that's the next thing that we're going to do is to convert NSP to a factor by creating, let's just create a new variable. Okay, I'll give you a few seconds to write that code. So the cardio data $NSPF. So we're adding this variable, and then it's as factor of the cardio data set, and then NSP. Okay, kindly do that, and then when you're done, please chat and run that class. Run yung si cardio to see if meron na ngang, if there's an existing NSPF variable at the end. And if you get the structure, kung si NSPF is factor. Okay, kindly chat please so that I know if you're okay already. I run this and I see that cardio now has 23 variables. Same number of observations. A while ago, there were 22 variables, but we added here and we named it NSPF. Okay, how about the others, please? Okay. Okay, thank you. Okay, good. A few more seconds. I hope the others are following along. Okay. All right. Now that we have created, so let me just print this dito sa natin. And here, ayan class, no? Si NSP, may natdagdag na NSPF. Pareho lang yan. Pareho lang yung values naman. However, okay, if I run the structure here, structure. Notice that my structure now, you have here NSP and then NSPF. So si NSPF factor siya with 3 levels. Okay, so let me pause and please just chat yes if you're following so far. Kung clear so far tayo. Okay, good. Okay. So you have to do that kasi pag hindi natin ginawang factor yan, class, magiging iba yung result. It will be treated as a quantitative variable. So iba yung magiging result niyan. Okay, so let's now go here. As you learned before, when we do machine learning class, we don't make use of the whole data. Okay, we split the data. We use different ways of splitting your data. Okay. Okay, we have done this in the past. So let's take a look at this. So kindly copy the code. We're going to set that seed so that we have the same observations. And then we'll create this object called PD, partition data. And we're using the sample function. we're going to sample the data, cardio data, into 2. And how many observations are there? There are n row of cardio. Cardio is our data set. Using n row means it will measure the number of observations. And then replace is equal to true. We also discussed this in the past. Replace is equal to true. It's just like drawing out one observation, and then you will have to put back that observation. Okay, and then shuffle, shuffle, shuffle. This is so in order to maintain the number of observations at 2126. Okay, so we're going to split it into 2. One set will have 80% and another set will have 20%. Okay, so let's run this first. Okay, so we have now this object PD here. And PD consists of, let me print this, head PD, say 20. So PD is now, it's a vector, okay, consisting of 2,126 observations. And then these are the numbers, the index actually. So all the number ones will go to one data set, and all the number twos will go to another data set, since we are subdividing our data set, splitting it into 2. Okay, so and then we create an object called train data set, and the train data set is subsetting your cardio data set with PD is equal to 1. Okay, so yung cardio data set natin, so the first observation, second, third, fourth observation will go to the train data set. This one, since it's 2, it will go to the validate data set. So we're now subdividing our cardio data set into 2, train data set and validate data set. Now, how did we split it? We splitted it using the sample function. So this randomly generates 2 sets of data here, 2, 80% of which will go to one, 20% will go to the other. Okay, so if you run this, okay, so let me now go to here, the train data set, 1718 observations. Okay, so we had 2126, I think, 2126 observations, multiply that by 0.8. So around 17. No? So hindi siya eksakto. We can use an exact figure for that. No? All right, let me just get water. I'll pause recording. Please remind me to continue. Okay, so we have effectively split our data. So even if we said that it should be 80-20, you notice that when we multiply the sample 2126 observations by 80%, it resulted into 17. So hindi siya eksakto, no? 18 observations yung train natin. Now, what's the purpose, class, of splitting the data into a training and a testing or validating data set? What's the purpose of that? Yeah, we're recording. What's the purpose, class? Maka-record tayo. What's the purpose, class? Anyone? Okay, can be to compare both groups, but there's one more purpose, class. More important than that is anyone, please? Anong purpose? What's the problem with using the 2,126 observations? class? To improve performance, okay. Letter O, class, letter O. To teach the model, yes. That's but I'm looking for one word, class. To teach the model, correct? I'm looking for one word. Okay, let me see. Optimization, not necessarily optimization, but rather it's also letter O. It's also letter O, class. It's to avoid what? To avoid. Okay, it's to avoid overfitting, no? Kasi pag ginamit natin lahat ng 2,126 observations na yun, ang mangyayari, class, we'll be creating a model that's parang tailor fit lang dun sa 126 observations na yun. And when new data comes in for us to test, baka masyadong ano na yung model natin, no? Masyadong in other words, kasi pati yung noise ng data, minomodel na rin niya. So that's why in practice, what we do is, in fact, yung ibang ginagawa, tatlong data sets, no? Training, testing, and then validation data set. Yung iba naman, dalawa, no? Training and validation, or training or testing. So the purpose is to, yung 80-20, Franz, that's what's the term for that? That's wala namang hard and fast rules, no? Na dapat 80-20. You can use 80-20 pag malaki naman yung, relatively malaki naman yung data set natin. Kasi 2,100 yung data natin eh. So if you get only 20% of that, in this case, 20% dun sa testing data, validating data set natin, 400 observations, that's okay. Okay? 400 observations, okay pa yon for our testing data set. I could have used 70-30, pwede rin naman yon, no? May iba nga lang yung balance. Parang masyado nalalaki din yung validating data set natin. So, walang hard and fast rules dito. Usually, it's depende sa size ng data, no? I've seen ML programs, ML processes that use 60-40. Usually, kapag maliit lang yung data set natin, no? You tend to pag maliit, class, you tend to put lower percentage dun sa training natin. Ito kasi malaki naman eh, no? 2,126. So this is arbitrary. Okay, wala namang but that's a very good question, Franz, no? So it's not 80-20 per se. We could have used 70-30. And is it possible for the model to be different? Yes, no? So maraming ano dito, class, maraming sabihin natin maraming assumptions na ginagawa, no? So maraming gray areas, maraming assumptions. So that's why it's important to make use also of other methods in order to make comparisons. Kasi dito sa 80-20, kung ang gamitin natin 70-30, pwedeng magbago yung natin, yung model natin. Yes, correct. It's entirely up to us. But of course, guided din ng certain principles, no? Okay, for example, 100 lang yung data natin, yung sample size. 80-20 might not work kasi 80 na lang yung 80 yung magiging magiging sa training. Tapos 20 na lang yung sa testing natin. That 20 might be too sparse for your testing. Okay? Sorry. Generally, may 60-40, may 65-35, may 70-30, 75-25. So far, the highest that I've seen is 80-20. Wala akong nakitang 90-10, no? Unless nakalimutan ko, baka may nakita ko dati. Okay? But it's all reasonable. It should all be reasonable balance between your training and your testing. And of course, mas malaki dapat yung training data. Okay, did that answer your question? Nasagot ba
Yeah.
class yung question?
Yes po, thank you.
Okay, thank you. All right. So, dalawa na yung dataset natin, 'di ba? May validating dataset na tayo at saka may training dataset na tayo. Okay. Ang gagawin natin muna dito, class, no? We will limit our variables. We could of course use all the variables. Okay, kaso it's highly unlikely na useful yung iba kasi kung tingnan nyo to, no? The others are just metrics, mode, mean, median na lang, no? Measured, minimum, maximum measure lang din siya ng ibang variables. So for our example, we're just going to limit it to based on the this data. Hindi ko na ano kung asa yung original ng data. I could have hindi ko makita, no, para we could have looked at the metadata. Pero we're going to regress and NSPF on pounds, and these are metrics dun sa heart, no? Heart condition ng tao. LB, AC, and FM. So we'll just focus on 3 variables. Okay. Remember, we could have used the usual regression stuff here. We could have used a GLM, generalized linear model here. Okay. And then that will be magiging multinomial siya, no? Tapos gagamitin pa rin yung yung log odds ratio nun. Tapos multinomial linear regression siya. Ito, class, decision tree to, ang gagamitin natin using machine learning. Okay, take note, class, machine learning is used for regression. Okay, iba nga lang yung method nito compared to the usual OLS, ordinary least squares. Magkaiba yon. Okay, so let's create this object 3.1. Okay, so in the interest of time, okay, i-share ko sa inyo yung first 2. The rest kayo na lang magsulat. Okay, for those of you who have not yet written this, okay, so we're going to do decision tree using the party package. Party stands for recursive partition. So I'm creating this object 3.1, and from the party package, ito yung sinasabi natin, no? Yung conditional tree. This is the power horse of the party package. And then we're regressing NSPF on LB, AC, and FM. These are the first 3 variables sa cardio. Yan. Wait. LB, AC, and FM. Okay, we could have used the others. No? I'll leave that to you to experiment on that. But let's just focus on the first 3. And data is equal to train. Okay, so take note, parang regression din to. Ang naiiba lang, hindi siya LM, no? Kasi sa least squares model, LM ang ginagamit. Ito, decision trees. Okay, ang gagawin yan, gagawa ng recursive trees, iba't ibang trees, yung model natin in order to classify our data. Okay? So let's run this first. 3.1, control enter. And then let's take a look at this. So ito ang sabi dito. Okay. So this is it's like a list, no? It's a large binary tree. Check natin. Party, Adi. Party. Party yung package nito, no? Ito, makikita mo naman dito, di ba? Ito, if you take a look at this, dapat alam, di ba? Alam nyo dapat na party na to kasi ginagamit ko siya ng namespace dito. Double colon. Okay, thank you for the question. All right. Ano yung object na 3.1 na to? Let's take a look at this. I-click ko lang dito sa data natin. So you notice, class, that it's a big data. It's a big data set. It's actually a list. So meron tayong ditong yung data natin. Okay. Merong responses. Yan, no? And then the tree, no? Andito yung tree. Alright, makikita natin dito kung paano ini-split yung data. Alright, but let's go to the object itself. Okay, so i-plot natin si 3.1. Plot. No, there. So this is our first decision tree. So simple lang, di ba? But what's important here is to understand what our model is telling us. Okay. Okay, so hindi siya masyadong clear dito, no? Pero may semblance naman ng pagiging clear. Alright, so we have here, makikita natin dito yung partitioning, recursive partitioning ng data natin. Alright, so here we have, this is your node 1, and it's basing it first on AC. So ang sabi dito, yung AC, if it's less than 0.001, pupunta dito sa node na to. If it's greater than 0.001, it will go to this node. Okay, so I hope you understand, no? So if the AC daw is less than 0.001, then go to this node, node number 2, you take a look at LB. And then you also look at if LB, okay, okay, sorry hindi siya 0.001 dito, no? Okay, I stand corrected. Let me discuss what the probabilities to, no? What the p-values here are. So una muna, nagkataon lang class na pareho yung 0.001 dito sa probability at saka dito. So the first node is AC. Take a look at AC, and if AC is less than 0.001, you go to pounds. If AC is greater than 0.001, you go back to AC. So ito yung mga decision rule, no? So dito class, kapag less than 0.001 yung AC, you go to LB. If it's less than 136, then you go to FM. If FM is less than 0.112, then ito siya, class. Ito siya, node number 4. Okay, anong ibig sabihin ng node number 4? Okay, number 1 siya. Normal. Okay, so hindi masyado nakikita dito. We're going to use another tree later. But you can see here that node number 4 predicts that the patient should be normal. Okay, ito na yung mga terminal nodes, class. Ang tawag dito, terminal nodes. Ito yung mga intermediate nodes, NODES. Okay, ibig sabihin hindi pa final. Pag dumating dito sa ilalim, final na to. Unfortunately, hindi siya masyadong kita, no? Yung number nito. Dapat may number dito, n is equal to. Okay, we're going to use another decision tree for this. Okay, any questions so far, class? One, two, three, four, five, six, 7, 8, 9, 10. Okay, 10. Kulang yung nodes dito sa final. Ibig sabihin hindi kaya ng ano natin ng plot yung lahat ng nodes. Okay? Hindi niya kaya. Okay, but let's take a look at this. Okay, di ba print natin yung tree? Ito 'yon. Okay, what will happen if we plot? Ito, ang gamitin natin plot 3.1. Ay, wait. Pareho lang, ano? Print, hindi, sorry. Plot yung rinan ko kanina, no? Okay, ito, class, plot 3.1, pero ita-type ko, I'm going to use type is equal to simple. Kanina kasi itong rinan ko, plot 3.1. Okay? If I modify it into type is equal to simple, okay. So medyo mas clear dito, no? It's the same tree. Okay. Okay. Medyo mas simple siya. Okay, ganun din to, class, no? Parang kanina lang, it's in a different format. So let's see what the meaning here is. You first choose AC as the basis. If AC is less than 0.001, then you go to node number 2, pounds. If pounds is less than 136, you go to node 3, okay, where we choose FM. And then if FM, wait, I think I missed discussing this a while ago, no? Okay, sorry for that, class, if I missed, kasi hindi clear sa drawing, no? Ito, class, yan, makikita natin FM to. If FM is less than 0.112, then ito na yon, class. This is now, the prediction is, anong prediction dito? Prediction is 1. How do I know, class? I know because, di ba tatlo yung ano natin, NSP. You have 0.711 for normal. You have 0.09 for number 2. And may pangatlo pa dito, no? Yung for number 3, yung pathologic. The probability of that is around 0.20, no? Kasi ito 71, and then 9, that's 80, and then the remaining is around 20%. So 71% malamang is normal siya. And there are 405 observations that fall under this category. Okay, I hope clear sa inyo, class, yung how the model is being done. Okay, so dito kasi 71% dito normal. So lahat ng ganitong condition, class, AC is less than 0.001, LB is less than 136, less than or equal to 2 yata. And then FM is less than or equal to 0.112, then this will go to this node number 4. Ang prediction nito, normal siya. Normal yung respondents, no? And then there are 405 observations that fall under this one. Okay, so this is a decision tree, class, no? So nagre-recursive partitioning yung ano natin, si party, to come up with a decision whether it's an N, an S, or a P. So pagdating naman dito, class, ito, take a look. AC is less than 0.001, LB is greater than 136, it will go to node number 6, where the probability for it to be normal is 40%, the probability for it to be suspect is 0.49%. So dito, class, itong node number 6, ang prediction dito, pag less than 0.001 yung AC, and then greater than 136 yung LB, then the prediction is suspect siya. And there are 314 observations that fall under this. Okay, pause muna ako, please. Feedback, please, if you're getting this, please. Nakukuha ba, class? Paki-chat naman, please. AC and LB are ano to, yung variables that measure the heart, no? As I said a while ago, hindi ko lang nakuha yung metadata niya kung ano ibig sabihin. But these are measures that were done on those who were examined. AC, LB, pounds to, no? LB is pounds. I think this is the weight in pounds. AC, measure ng heart to, ng heart, something about the heart, and also the FM. Okay, if I get the metadata, I'll share it with you para guided tayo kung anong ibig sabihin. Sorry, hindi ko na ilagay. Okay, so dito naman sa node 7, if the AC is greater than 0.001, punta tayo dito. Okay, tapos titingnan natin, is the AC greater than 0.002, less than 0.002, or greater than 0.002. So in-split pa niya, no? Tinignan niya kung 0.002, less than, at saka greater than 0.002. And then, again, another partition here, no? So ganun lang siya, class, partition ng partition, until you reach the final node, no? These are the final nodes. These are the terminal nodes. So in this case, node number, you go here, node number 9, okay, node number 10, okay? So sa node number 10, ano to, class? normal to. Kasi ang ano natin, ang probability ng n is 0.874. So ito naman, normal din, 0.571. No way for the person to be pathologic to be classified here kasi 0 to. Okay? So lahat ng mga yan, class, these are probabilities. And then they tell us how many either N, S, or P are classified. So mukhang maraming N, di ba? Kasi well, ang dami kasing observations na N. Dito 405 predicted as N yan. Ito, class, ito predicted as pathologic, no? 11 kasi 1 dito eh. Dito 0.401, dito predicted as S. Dito predicted as N. Ito N ulit. Ito N. N, 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 N. So the rest are N. Iisa lang yung sa iisa lang yung sa suspect, ito lang. Node number 5. Sa suspect, iisa lang din, ito node number 6. The rest are telling us that these are normal. Okay? Of course, mababago yan, class, kung kung medyo baguhin natin yung trees natin. All right. So this is one way. Okay, let me share this with you in the interest of time. Okay. So if you take a look at the syntax of C3, meron tayong tinatawag na minimum criterion, no? So, and it's found under controls, no? Controls is equal to, so pareho lang yung una, no? Ang default, diba? Ito lang. Tapos, pwede tayong magdagdag ng mga other parameters to redefine our decision tree. Dito, ang minimum criterion 0.9. Tapos dito ang minimum split 50. Ano ibig sabihin nito, class? Kasi dito, 'di ba, makikita niyo na may n is equal to 12, may n is equal to 28, may n is equal to 7. Dito, class, pag sinabi niyo minimum split is equal to 50, okay? Magi-split lang siya, class, kung merong at least 50 na respondents. Ibig sabihin nun, class, kapag ang minimum dito 50, ibig sabihin nun, then most probably there will be lesser nodes, terminal nodes. Okay? Kasi kunyari ito, hindi pa pwedeng 11 lang to, no? Ito 7 lang eh. Ito 18. Okay, if you're going to set the minimum split at 50, then what will happen is that we will have bigger terminal nodes, no? Okay, and then minimum criterion is 0.9. Okay, so ang minimum criterion kasi natin dito, di ba? Probability yun eh, no? Okay, let's run this first. So let's create this object 3.1a. Tingnan natin, class, kung ano mangyayari dito. So meron tayong 3.1a dito, no? Dito sa object natin. Okay? And let's see if we plot this class. Kanina, yung tree natin dito, 18 nodes all in all. Dito, malamang, class, mas konti, no? Mas konti kasi mas marami tayong linalamp sa isang terminal node. Okay. Okay, dito, wait, baliktad yata ako. Ba't dumami yung terminal nodes natin? Kasi because of this minimum criterion, ano? Wait. Okay, sorry class, let me check. No? Medyo na-confuse ako dito sa minimum criterion na linagay ko dito. Kasi it's not the probability. No? Wait lang. I was expecting that the terminal node should be smaller. Just help me, class, check in your own time kasi magta-time na, no? Yung minimum criterion, no? Okay, dito na lang, tingnan natin. Okay, how did our controls nakalimutan ko na kung paano niya inano yung minimum criterion. Here guys, ito. The minimum criterion is the type value of the test statistic 1 minus p-value that must be exceeded in order to implement a split. Okay. So, ganun nga, no? Ang minimum criterion is, ito yung p-value class, no? So, dito, sa una, ang p-value natin is 0.0, ang default is 0.05. Dito, ang ginawa natin, ang default natin, ang ginawa natin na minimum criterion is 0.10. Okay? So, anong effect nito, class? Ang effect ng increasing the minimum criterion from, decreasing from 0.95. That's the default kasi, di ba, class? 0.95. Decreasing it to 0.9, ang tendency nito, class, dadami yung mga natin. Dadami yung mga nodes natin. Okay, let me just check, class, ha? So, gawin natin, kunyari 0.99. Okay, everything the same, class. 0.99. Let's see what happens. Okay, tinaasan ko yung minimum criteria ng 0.99. Alright, plot that 3. Okay, ano nangyari? Simple. Naging 15 na lang, no? Naging 15. So, in-increasean ko to, naging 15. Nung 0.9 lang siya, 20. Pag 0.95, para pare-pareho yung yung comparison. Okay. Plot ko. Sorry class, nakalimutan ko yung gamit ng Alright, 16. Okay. Yung 0.9 class, ilan siya yung 0.9? 0.9, 20, di ba? 0.9, naging 20 yung terminal nodes eh. Yeah, 20, no? 20 in terminal nodes. So, okay. I think we need to look also at the minimum split, no? So, basta class, ang minimum criterion is, it tells us kung kailan nagiging significant yung isang split. So, pag ginamit natin na 0.9, it means that dapat 90% yung, dapat 10% yung level of significance para mag-split yung natin, yung 3. Pag 0.99, dapat ang level of significance natin is only 1%, no? Yung default is 0.95. Okay, so a lot of things pa sa minimum split natin dito, the minimum sum of weights in a node in order to be considered for splitting. Tapos may minimum bucket pa. Ang point dito, class, you can fine-tune yung decision trees natin. So you may come up with several different terminal nodes. Ang laban naman dyan, class, hindi yung number of terminal nodes eh. Ang laban dyan yung yung validation yung pag-test ng dataset natin, yung errors, no? Ilan yung tamang na predict niya. It's not the number of nodes, although, class, theoretically, the more nodes, class, the better is the chances of correctly predicting. Kasi imagine kung lilimang nodes lang, di ba? If there are 5 nodes, then the chances for a correct prediction might be less than, not even will be less than the prediction if you have 10 nodes. So nagkakatalo dun, class, no? And there are other factors that we can use. Kaya hindi ko na nga ginamit dito eh. May M-try din. I think dito sa susunod. Yeah, naggamit ba ako ng M-try dito? Hindi ako nag-M-try eh. Okay, anyway, so I would that you just experiment, no? Tingnan nyo kung ano yung mangyayari. Alright, so let me go back to what I did a while ago. Minimum criterion is 0.9 ang ginamit natin. Minimum split is 0.5. So if I run this, okay, and if I print, diba, ito yung nangyari, naging, saan yung print? Oh. Okay, this one. Ito na lang, simple lang ipiprint ko. Okay, here. There are now 22 na pala to, no, class, no? 23, sorry, Yes, Adi, anong question mo?
Sir, anong code nga po yung, anong package po yung gagamitin for the tree function po?
Hindi, party pa rin to.
Party pa rin siya.
Oh,
Di siya.
C3 to, C3
It
yung
says, sir,
function.
sa akin na could not find function C3.
Linood mo na ba si party? Nag-library ka na ng party?
Yes po, yes po.
Sure ka? Check mo nga kung baka kanina ang ginawa mo lang ito. Sinulat mo yung party dito. Kaya magkaroon pa rin to pag sinulat mo yung party. Pero pag tinanggal mo
sige.
na yung party dyan, hindi na niya alam kung kung anong package yan. So you have to
Okay, sige.
You have
Check
to
na lang,
load it
sir.
first. Hindi mo pa load yan, definitely. Ito, hindi ka pa nag-library ng party. Okay, as I said, no, lesson for us class, ito nag-run. Kasi in-identify natin, di ba, yung namespace. Sabi natin class na even if you don't load the package, pag in-identify mo naman dito yon, usually mag-run yan. But in this case, okay, ayan, no, hindi mag-run yan kasi hindi niya alam hindi natin define kung anong package. So if you want to run this without identifying the package, i-load mo siya. Adi, paki-confirm nga kung nag-run na. Okay, it's good. Thank you. Thank you. All right, good opportunity for us to learn. All right, ito 23 pala class, no? Kanina 18 lang. So ang ginawa natin, yung minimum criteria natin 0.9, tapos nag-minimum split tayo 50. Okay. So may class yung mean split. I stand corrected, hindi siya ibig sabihin ng isa lang, no? 18. Ang ibig sabihin ng mean split class is that, okay, the minimum sum of weights in a mode in order to be considered for splitting. Ibig sabihin class, bago siya i-split, okay, dapat may 50 muna. Okay? Dapat may 50 muna dun sa root 3, no? Kasi kunyari kung 40 na lang yung elements dun, kunyari dito class, dito. Ang natitira na lang dito, let's say 40 na lang, 40 observations. Hindi na pwedeng split yan. Dapat magfa-final mode na to. Okay, so I stand corrected. Hindi yung 18 at saka dito kanina, no? All right. So okay, so this is another trial naman. Ito minimum criteria natin 0.999, tapos mean split 500. Okay, I'm calling it 3. Okay, para mas mabilis tayo. So magta-time na. Okay. Shinare ko na yung code class, no? So let's run this. Control Enter. And then I'm going to plot. Okay. 0.999 tapos minimum split 500. Okay. Tingnan nyo to class, no? Ang konti na lang ng partition. Ang konti na lang ng partition. In fact, class, yung partition natin, 4 na lang yung final nodes. And if you notice, wala nang prediction for suspect. Ito, normal to 0.692 yung probability. Ito, this is suspect I mean pathology kanina, no? Suspect to 0.497. This is normal. This is normal. So this will be prone to a lot of errors, no? Kasi wala nang ano eh. Wala na predict na pathologic. Lahat N or S, walang P, no? So hindi rin maganda class kung masyadong malaki yung ano natin, no? Giving it a minimum split of 500 class means that pag less than 500 na yung root node mo, hindi mo na siya pwedeng split. In other words, yan ay magiging final value mo. Okay, that's why if you take a look at this class, ito in-split niya, 416 plus 314, this is 700 plus ang galing dito. So pwede pa niyang split, no? Kasi ang pinanggalingan nito 700 plus dito. Ito naman 188 plus 800, that means that ano siya, no? Na 900 plus. Okay, so what happened here class was ito hindi niya in-split, no? Hindi na. Kasi less than 500 na to eh, less than 500, less than 500. Ito pwede pa sanang i-split pero hindi na niya in-split, no? Okay. Now, it's almost time class. If you need to go, please do so. I'll just validate the ano, no? Para sa recording lang class. So evaluate na natin class yung ano, no? Okay, here. Evaluate na natin yung model natin. All right. So gamitin natin class si 31B, 3.1B, ang pangat ng 3.1B kasi malaking error terms ito. Ang gamitin natin class si ano, let's use 3.1A na lang, no? Na model, no? All right. So I'm going to use 3.1A here. Control C. Chat ko na lang. Yan. Sinishare ko na class yung code na to, ha? Okay. 1A to, sorry. This is 1A. Okay, i-test natin si 1.A. Kasi from the looks of it, mas maganda si 3.1A kaysa 3.1B. So I'm creating this object, predict1, P1T na lang, and then I'm using the function predict. Okay, predict 3.1A, and then for the train data. So ang gagawin natin class, using the 3.1A, ipapaprint natin yung mga predicted values. Okay, i-run ko to. Okay. So take a look at this class. All right. Ito yung train data set natin, ano? Sorry, yung train data set natin. Okay. All right. Now let's compute for the misclassification. I'm creating this object table.1a. Okay. We're going to compare yung predicted natin is equal to predicted value natin is the prediction from 3.1a versus the actual ng train data set natin ng NSPF, no? Train data set $NSPF. So, pag-create tayo ng table, okay, control enter. Okay, print natin si 1A. All right. So take a look at this class. This is how our model performed. Ito yung predicted. Okay? Predict natin. Ang predict na 1 is 1304. Na ang actual niya 130 normal. So tama tayo dito. Predict niya na normal pero ang actual niya is suspect. Predict niya na normal pero ang actual niya pathologic. Okay, ito class, predict niya as suspect. Ang tama sa kanya 95 suspect. Mali ito, no? Mali din to. So in other words, class, ang tama lang dito yung diagonals. Yan. The rest are wrong predictions. Okay? So let's sum up the diagonals, okay? Sum up the diagonals divided by the total of this table to get the percentage of correct prediction. And 1 minus that is the percentage of wrong observations. Okay, hindi nabigay yung ano. Okay, ilat ko na lang dito. Ano mali? 1 minus sum. Okay, 82% ang tamang prediction, 17.9% ang maling prediction. Okay, compare natin siya, class, si 1A kay 1B. Di ba si 1B yung ilan lang, 4 lang yung terminal nodes. Okay, same ano class, same codes. All right. Chat ko na lang sa inyo. Okay, pareho lang this time. Ang gagamitin natin ng model, ang pre-predict natin 3.1b. Okay, everything is the same. Okay, so if I run this, okay, ito na muna. Hindi ko na ipiprint yung ano yung tama, ipiprint ko. And this 3. All right. So ito class, no? Mas maraming error terms to. In fact, 80% lang yung ano niya, yung batting average as compared to 82 kanina, no? So a big difference, 82% yung tama ng 3.1a and 3.1b. It's because I said the less terminal nodes you have, the lesser will be your accuracy. Okay? All right. And then now, syempre tapos na natin class si ano tapos na natin si training dataset. Let's see how our model will perform. Dalawa ko na to, class. Control C. Using now yung validation dataset natin. Okay. Ito yung data class na hindi pa nakita ng model natin. All right? So this time, I'm going to use the same prediction class function, but this time, gagamitin niya si validate. Hindi niya gagamitin si train dataset. Okay, so this is P1, kanina P1 train, ito P1V validate. No? So ito yung mga prediction. 1, 1, 3, 1, 1, 2, using the validate dataset. Okay, ito yung predicted niya. Tapos, if you want the probabilities class, ito yung code, no? Type is equal to probabilities. Okay, so, ano ibig sabihin nito, class? Observation 1, 98% probability na normal siya, 0.4% na S suspect, and 0.6% na pathologic. So that's why, ito class, tinun to 1, no? Ibig sabihin, normal yung prediction dito. Okay? Sorry. Hindi. Ano to, yung data number, no? So ito 1 din to. Yung kanina yon ito, no? Yung sa predict. Okay? So yung mga values na yun, 1, 1, 1, it came from the probabilities. Saan yan, Mike? Okay, Mike, tapusin ko lang to and then I'll get back to you, no? All right, then na-model natin class si P1V, just like what we did a while ago. Ito binigay ko na sa inyo, no? Okay, run natin to. Ito na lang ira-run ko. So I'm going to create a table para makita natin kung ilang percent yung okay. So dito class 79.9%, practically 80%. 80% yung performance ng model natin when we subjected it to a data that it has not yet seen, yung validate data set. Okay? 79 versus 82. Okay, so is it good or not good? Well, it really depends, no, on the parameters that the researcher is using. Okay, but 80% versus 82%. Personally, I would say that for a data that has not yet been seen, it works well. No? It still works well kahit na yung data hindi pa niya nakikita, no? Yung validation data set. All right. So it's already time class. I'm sorry about this. So next meeting, ewan ko kung kakasya to, hindi yata. Control C. Kindly see if you can copy this. If not class, I'm going to post this later on. Okay. I'm going to post it later on sa okay, saan na ako? Asan yung chat natin? Ito. Pa-post ko sa natin class sa Canvas. Mali. Yung picture ng ano yun? Copy. Control V. Hindi kasha class. Okay, so kulang na ako sa oras. Ipo-post ko na lang class yung ano. Our part is another package. So pareho din naman yung process class, but this time for me I prefer using our part kasi mas maganda yung plot niya. Okay? So everything is the same class. Everything is the same. Okay, at least yung first two. Okay, i-ano ko na lang class, split ko na lang, no? Yan, yung una. Tapos ito yung last. I-copy nyo yan class so that next meeting, ano na tayo, no? Ayan, okay. Paki-copy siya class, try to run it, no? May I request you to do it class para next next meeting natin. I think class I will have to hindi ako pa pwede sa Sunday, maraming ano. Okay, sige, so ano na lang. So ang problema ko sa Tuesday, doon na naman tayo sa classroom. Yung problema ko dun sa ano. Anyway, we'll just resolve that later on. All right, I hope you learned something today, class. Thank you so much. And I'll see you next class meeting. Oo nga eh. Franz, gusto ko sana online kaso nag-check yung registrar eh. Yun ang problema ko. Nag-check yung registrar ng ano na face-to-face. Eh hindi sa atin effective yung face-to-face eh, di ba? Yeah, I would mas gusto ko kasi mas nakaka-discuss tayo eh. Kaysa doon magbubukas pa ng RStudio, minsan RStudio does not work. Post-it does not work, Post-it Cloud. So, 'yun ang problema natin, no? Okay, anyway, let's see what we can do.
Got it, sir. Thank you po.
All right, if I'm able to find a way na mag-online pa rin tayo, I'll do that, no? Para mas maganda. All right, yung magpapa-check ng attendance at saka sino nagtatanong kanina? You may go class, you may go, ha? I'll
Bye.
stop.
You.
Bye-bye, thank you.
Ay, sir, yung sa misclassification error for validate dataset using model 3.1